Okay, so today we're going to talk about creating one-step equations from models and from real-world situations. We're going to start with the real-world situations since they're a little bit more relatable. We see that Alejandro has a deck box filled with Yu-Gi-Oh cards. In addition to that deck box, he also has 5 additional cards that he won at a tournament. He has a total of 66 cards. So we need to figure out how many cards he has in that deck box. Well, we don't know how many cards are in the box, so we're going to use something to represent an unknown number. We're going to use a variable, in this case, the letter x. X can be any number. We just need to figure out what it is. In addition to whatever's in the box, which is x, he also has 1, 2, 3, 4, 5 additional cards. So he has whatever's in the box plus 5. And then this is going to be a total of 66 cards. So Bob likes to go to yard sales and collect things that look rare, things that look valuable. This time he happens to find 4 very rare coins. He takes them to a collector and he sells them and he gets $5,000. So this is a really good find at the yard sale. But how much is each coin worth? Well, we can figure that out by setting up an equation. Here we have 4 gold coins. We don't know how much each coin is worth, so we're just going to say that each coin is worth some unknown amount, some amount we don't know. In this case, X. Each coin is worth X number of dollars. Now, here we can see that he has 1, 2, 3, 4 coins. So the total amount of money that Bob can make by selling these coins is 4 times however much each coin is worth, or 4 times X. We're going to represent this by putting the 4 right next to the X. If they're touching, then this is going to mean that's 4 times X. We just say 4X because mathematicians are lazy. Now, how much are 4 of these coins worth? Well, they're worth $5,000. I need to shop yard sales in Bob's neighborhood. So let's say you have a bag of Jolly Ranchers. Jolly Ranchers are tasty and delicious. Everybody loves Jolly Ranchers, and if you don't, well, you're just wrong. But there's a problem. Even though you have a bag of delicious Jolly Ranchers, you don't know how many Jolly Ranchers you have. You just know that you have a bunch of them in a bag you can't see. One day you decide to reach in and have yourself a delicious watermelon-flavored Jolly Rancher, or maybe sour apple, or maybe blue raspberry. But as soon as you reach in, you see ants. Ants all over the place. And these ants have attacked your Jolly Rancher. So unfortunately, you have to throw away 6 Jolly Ranchers that are covered with ants. And in the end, after you dump out the bag, you're only left with 2. It's tragic. How many Jolly Ranchers did you have originally? Well, that's something we can figure out, but first we have to represent this problem with math. How many Jolly Ranchers were originally in the bag? We don't know. So we're going to use a number x, a variable that represents a number that we don't actually know. We had to throw away 6 delicious Jolly Ranchers. So we're going to use subtraction to represent that. We are minus 6 Jolly Ranchers that went in the garbage because of ants. How many Jolly Ranchers are left? Only 2. This is how you represent the situation with an equation. When we use the Brainingcamp system, the manipulatives all look like this. You have these rectangular bars and you have small squares. The green rectangular bars each represent an X. The small yellow squares, and I don't have a yellow marker, represent 1. The red rectangular bars are a negative x, taking an unknown amount away. And the small red squares are negative 1. You're subtracting 1 of something. In a situation like this one, where we have an equal sign representing an equation, if we have 2 green bars and 1 red square, so if we see 1 green bar and 3 yellow boxes on one side of this equation, that tells us that we have one single x, and in addition to that single x, we have 1, 2, 3 constants. So this would represent x plus 3. On the other side of the equal sign, we have 1, 2, 3, 4, 5 constants. So this represents the equation x plus 3 equals 5. So what if we have an equation like this? On the left side, we have a red bar, meaning that's a negative x, and 3, well, they're supposed to be yellow squares. So these are positive constants. So we have a negative x and 1, 2, 3 that we are adding to that x. So this is negative x plus 3. And on the other side, we have 2 negative constants. So that means this is equal to negative 2. One last example. If we have 3 red bars, that's 3 negative x's. So on the left side of this equation, we have minus 1x, minus 2x's, minus 3x's. So this would be negative 3 x's. On the other side, you can see that we have red squares as well. So these are negative numbers. Negative 1, 2, 3, 4, 5, 6, 7, 8, 9.